In this project, I am going to demonstrate how you can monitor plant health and build a hydroponic system with the help of the Idiotware Shield. You will need the following things to get started: an Arduino Uno, Idiotware Shield, 2 soil moisture sensors, a DC motor, an IRF520 N-channel MOSFET, one 1N4004 diode, one DC-DC buck regulator, 10 female jumpers, USB cable to connect Arduino to computer, one 2-pin jumper, a 12-volt power adapter. Idiotware Shield Automated Plant Care. Please install all libraries from our GitHub repository to enable this example to run. In this example, we are using an ESP826601 Wi-Fi module with ESP-Link firmware, soil moisture sensors to sense moisture in soil, water level sensor to detect water level, and motor to water the plant. If plant soil is dry, then moisture sensor will give high input to Arduino. Arduino turned on the motor. We have used a MOSFET to turn on and turn off the motor. Arduino logs the data on ThingSpeak and sends email to users. ThingSpeak is an open source Internet of Things application and API to store and retrieve data from things using the HTTP protocol over the Internet or via a local area network. ThingSpeak enables the creation of sensor logging applications, location tracking applications, and a social network of things with status updates. To log data to ThingSpeak, you need to create a ThingSpeak account and then create channels and use the channel's API key in this code. We are using IFTTT to trigger an event. IFTTT is a free web-based service that allows users to create chains of simple conditional statements called recipes, which are triggered based on changes to other web services such as Gmail, Facebook, Instagram, and many more. IFTTT is an abbreviation for if this then that. You have to create an account on IFTTT to create your recipe. We are using the maker and the Gmail channel to trigger an event. If the plant is watered, Arduino will send post requests to maker channel. If maker channel is triggered, then Gmail sends an event called plant watered and an email to any user around the world. We have to include two libraries in this code called the EL client and the EL client list library. These libraries allow us to connect the Arduino to the ESP01 to make get and post requests. We have to connect the water level sensor and the moisture sensor to pin number 7 and 5 of the Arduino. The motor is connected on pin number 3 through a MOSFET. Please copy the ThingSpeak's API key from your ThingSpeak dashboard and copy it here. Initialize the EL client ESP object with the two serials of the Arduino. The Wi-Fi CB function is called whenever the ESP connects to Wi-Fi. A Boolean variable called Wi-Fi connected is set to false, but when Wi-Fi gets connected, it is set to true. Only when Wi-Fi connected variable changes state from false to true is when we should make HTTP requests to either IFTTT or ThingSpeak. This is handled in code. In the setup function, we have to initialize the EL client library, and the code allows you to synchronize the EL client library with the Arduino code. Once the synchronization is done, we set the moisture sensor and the water level sensor pins to inputs. The motor pin is set to output, and immediately the motor pin is set to low. This makes the motor stop moving. The moisture sensor state and the water level state is constantly polled in the loop function. Whenever the state changes, an appropriate action is taken. For example, when the water level sensor is high, it turns off the motor. Why? Because there is no water in the bucket. Then it goes to IFTTT and makes a request to the maker channel, notifying a person that the water level indicator has gone low and new water has to be filled. After the mail is sent, it goes back and checks if the moisture sensor state is high. When it is high, it means that the soil is dry and the plant has to be watered. Of course, both the events are highly unlikely to occur together. If the moisture sensor state is high, then it goes to api.thingspeak.com, makes a request to using the API key received from ThinkSpeak, and it logs the data to ThinkSpeak that the plant has been watered. It then turns on the motor using the motor start function in the program. It turns it on twice after a delay of 500 milliseconds. Once the motor is turned off, it goes to IFTTT again and triggers the event called plant watered with the API key. This will send an email to the user that the plant has been watered. There are additional functions that abstract the actions of logging to ThinkSpeak, logging to maker channel, and starting the motor. These functions can be used in other programs as a starting point for you to try out new ideas.